Hello guys, I welcome you all. I hope you all are doing well. Yeah. So Pentester Academy has its July sprint ongoing and I am taking a part in this competition. Okay. They have provided their premium labs for free for the ongoing competition. So yeah, here are a few labs: CVE 2022 26180, fixed misconfigure Apache web server, DLL hijacking, confining services with app armor, and weakest link. Yeah. So, and I'm going to give a walkthrough on the lab DLL hijacking on DVTA app. Okay. So let's get started. Okay. So let's head over to our lab. So I have already opened the lab. Yeah. So this is the lab, as you can see, DLL hijacking DVTA. So this is mode of a Windows privilege escalation. Okay. More details of the lab is given over here. Okay. So for this lab, we mainly have two machines, two Windows machine and one Kali Linux machine. So the two Windows machine will be having so one with the low privileges and other with the administrative privileges. Okay. Yeah, and the main objective of this lab is gaining access to administrator privileges using Meterpreter session. Okay. So yeah guys, let's get started. We also have lab walkthrough video if you face any difficulty. So let's click the run button. Yeah, and meanwhile you can check this amazing website of Pentester Academy. We have everything in line. Okay, can go through this when you get time. We have our lab loaded. Let's click the lab link. Let's wait for it to get loaded. This is a collaboration of Pentester Academy plus INE. Okay. Yeah, as we can see, we have two machines, the Kali machine and two Windows machines. Okay, this is the attacker, that is the student or low privileges one. This is the target machine or the administrator privileges machine. So yeah, so our labs are loaded, as we can see. Attacker machine, target machine. Okay, so target machine is the one with the administrative privileges. For this lab, we'll be working with the DVTA app. DVTA. So DVTA is nothing but the damn vulnerable thick client application, which is intentionally vulnerable application, which we'll be using here today, and we will be performing DLL hijacking. Okay. So what exactly is DLL and why is it used? So DLL stands for Dynamic Link Library. Okay. These are shared libraries and any application can use them if required. It's like a common resource or common library resource which any application will be using whenever they require. So if we have any DLL missing, then we can try to create some malicious DLL and then we can escalate them accordingly. Okay. So we will be using a tool to monitor our DVT app, and the tool name is Process Monitor. So this is Procmon. Okay. So let me give you a brief info about the Process Monitor tool. So Process Monitor tool is an advanced monitoring tool for Windows that shows real-time file systems, registries, network activities, processes, or thread-related activities. Remember that this application need admin privileges to run over it. Okay. Let's open that. So the Process Monitor application doesn't come installed by default and needs to be downloaded from Microsoft website. So yeah, this is how this application looks like, Process Monitor tool. Make sure that your capture events are on so that it could capture all the real-time data. To know more about any event, we can just double click it and we will get more details. So, yes, so let's run our DVTA app. So yeah, our app has started running. Let's filter out and see only processor related with our app, that is dvta.exe. Let's add and okay. Yeah, we can see the all processor now only the DVTA.exe. Okay, so since we are not interested in the registry and network activities, just uncheck them. Here we will be requiring only the create file operation. So just right click and just include create file, and we can see only the create file options now. In the result section, we can see name not found. Okay, so include them as well. Yeah, so we have sorted results. So let's now further scope down to our DVTA. We can see this DLL file is related with our DVT application. Okay, so just copy the DLL path, just double click it. This is the path, just copy it. We'll be having all our DLL files over there. Go to the filter, just add the path, and yeah, begins with. So yeah, so this are our specific results which we are looking forward to. So finally we have the sorted filters results. So yeah, so this is the file we are looking for, dwrite.dll, which is the missing DLL, and which we will be further exploiting. So before starting exploiting, let's check if our student account or the account with the less privileges has proper write access to the DVT app. Let's open window PowerShell. So I have used that get ACL command to know the privileges we will be having to this path. So here we can see that privilege SQL student. So the student account has allows full control over this path. So this path we have all the privileges so that we can write also. We have read write access. So yeah. So let's start exploiting. Since we know that dwrite.dll file is missing, now we can generate a malicious DLL file using the Metasploit framework to exploit the DVT application. Okay. So for that, let's open the Kali Linux machine. Let's check the IP address of our Kali Linux machine. So yeah, inet. So this is our IP. We'll be requiring it for our payloads. Okay. So yeah. Now let's generate a malicious DLL payload using MSF Venom. That is a Metasploit framework. Let me quickly copy the commands. So yeah, we are just copying this commands and writing it over into the file name dwrite.dll, and this will be our malicious payload. Okay, I hope the file payload has been generated. Let's check the details about the file. Yeah, so it shows PE32 executable DLL file for MS Windows. Yes, so our payload has been successfully generated. So now let's host this file on our simple Python server so that our attacker could download this generated payload and use it for further exploitation. So just hosting this path over here. Yeah, so let us download the file. Yeah, I hope the file has been downloaded. Let's check. Yeah, so we can see the file has been downloaded. which we hosted from the Kali Linux machine. Okay. Now let's move this file to our destined path, that is this one. Okay, so we need to move the file from this position to, let's copy this path. Yeah, we have moved it. So let's check. Okay, we can see that our file has been successfully moved to our destined path. So to quickly understand what we have done is, we have used our Kali Linux machine to generate the malicious DLL payload, and we have hosted it so that our attacker machine or the low level machine, or the machine having with the lower privileges, can download it, which we have done it in this step. And then we have moved that payload to our destined path, that is the DVTA.exe applications path, so that we can further exploit it. So now we have successfully injected our malicious DLL file payload into our test target machines DVT applications. If you can see over here, okay, dwrite.dll, this is our malicious payload which is injected here. Okay, now let's exploit. Move towards the Kali Linux machine. Now let's open MSF console and run multi handler, okay, which will handle our exploit which we have placed elsewhere, that is our target machines DVT applications. Okay, let's paste the payload over here. So yeah, so a reverse TCP handler session has been started and we are actively listening. Let's open our DVT application now. Let's see if we can get anything on the Kali Linux machine. So I have run the DVT application. Okay, yeah, so we can see that our session has been captured over in the interpreter. Let's see if that works. Get UID. So our name, we can see that we have got the administrator. Okay, sysinfo. Yeah, so we have all the details of our target machine over here. So yes, we have successfully achieved the shell of our attack machines using our malicious DLL which we placed in the DVTA. Yes.